to show you what a noise gate really is, I think it's best that we use an example where a noise gate is most commonly used. Now, that would be vocals. So let's hear this in a complete sense, like the entire song with the vocals.
I was slipping into the shadows of the night, waiting for the darkness to arrive, falling into the dark, seeing the stars in your eyes. They're lighting up my sky.
Now that would be it for the vocals. So let's see why we would use a gate right here. Well, we have some of these breathe-ins while she's singing, and to play you those more carefully, I'm just going to remove this delay right there. So right here, I'm going to remove all of these effects. Let's play that solo.
I was slipping into the shadows of the night, waiting for the darkness to arrive, falling.
Now you can hear that aside of those breathe-ins and breathe-outs, we do have some of these lower, you see vocals, her smacking lips on the mic, and we can remove those by just actually deleting those, and we can use a gate to do that. So imagine if we had a really long piece of vocal. I would always prefer to do it, by hand, but imagine something like, let's say, a voiceover for an entire movie. The best thing to do with it would actually be to use a noise gate, because that automates the process. Now let's get into what a gate actually is. So I'm going to place that on the track and show it to you. So what is a gate? Well, just like a compressor, it's a dynamic effect, and it also has a threshold as its set parameter. So the difference between a compressor and a gate is actually in how the threshold reacts. So in a compressor, we are affecting only the pieces of the signal that pass over the threshold, that are louder than our threshold. In a gate, we are only affecting the signals that are quieter than our threshold, meaning that we only dynamically affect the signals quieter. So both of these, the compressor and the gate, will attenuate signals, but the compressor will attenuate the signals that go above the threshold, and the gate will attenuate signals that are under the threshold in this loudness sense. So what does that mean for us? Well, that means that anything that is quieter than this threshold is going to get floored, minus 40 dB. So if this breathe-in stays quieter than our threshold setting, we're not going to be able to hear it. Anything that's quieter than the threshold, we won't be able to hear it. So let's start with the threshold all the way down. Now we can hear the entire vocal. And as I bring the threshold up, more and more pieces of this vocal start to disappear. Let's hear that.
I was slipping into the shadows of the night, waiting for the darkness to arrive.
So see, we're also losing some pieces of the vocal. But if I really set up this threshold to catch only this breathe-in, so that level, let's try that. You see, it was actually under the threshold, we couldn't hear that.
Waiting for the darkness to arrive.
So see, no breathe-ins, no lip smacking. We don't hear that. You can even see them on the graph that they are under the threshold, so we don't hear them. If I disable the gate, you can hear the breathe-in.
Falling into the dark, seeing the stars in your eyes. They're lighting up my sky.
So this way, I have automated the process of removing the quiet parts from the signal. And called a noise gate because you see here it's only a gate, but the popular term for it is the noise gate, and that's why it was primarily used to remove any noise. So when recording with a mic, a preamp, and all that, all of the noise gets exaggerated. So between every phrase that the singer sings, we also have that noise printed onto the channel. Now we can go around and just cut out every silent piece or something like that, but we don't have to do it. You can just implore the gate, and the gate will do that for us. So the gate, as a dynamic signal, affects all of the signals, affects all the pieces of that signal that are quieter than the threshold we set. And it also has the attack and the release. So attack is how fast it's gonna let go after, removing everything. So let's see how the attack is going to affect on this start right here. So we will not hear the breathe in.
falling,
So you see immediately fall in. Okay, so let's go up with the attack time and see what that's gonna do for us.
falling into the dark.
So you see that started nicer, not so abruptly like with the F, with the first F. So let's hear the difference again.
Falling, falling into the dark.
But now we also have the problem of all the rest of these transient pieces of the vocal that start abruptly. They're also not so punchy, and we are losing pieces of that vocal, so we have to be careful with the attack.
Falling into the dark, seeing the stars in your eyes. They're letting out my sky.
So the attack time tells the gate how fast to let go of the gate, to let go of the signal once it's actually passed over the threshold. So it's the opposite from what it did in the compressor. The attack would tell the compressor how fast to actually compress. Well, for the gate, it actually tells the gate how fast to let go. And the release would also be the opposite from the compressor. So in a compressor, the release would tell the compressor how fast to actually let go of the compression, which is what the attack is doing here. And here the release is telling us how fast to start compressing. So let's hear that.
I was slipping into the shadows of the night, waiting for. I was slipping into the shadows of the night, waiting.
So you see that? If I put it all the way up,
I was slipping into the shadows of the night, waiting for the darkness to arrive.
this means that it's not going to actually completely start gating out the signal before the next line. We're not letting it start compressing immediately, to start gating out immediately after this one finishes, to start gating out this quiet piece, so we won't have a problem with the start of the next one. So the release tells it how fast to actually start compressing after this one has passed under the threshold. So quite the opposite that in a compressor. Now we also have this hold parameter right here that gives us the minimum amount of time that the gate is going to stay open. So once the gate opens and it's not diminishing the signal completely into zero, as we put it right here into minus infinite. So the moment it's open, this is the minimum amount of time it's going to stay open. So what we can do is avoid the signal going down between single words. Only when the phrase is finished, it can start going down, because then the hold is going to help. So the hold parameter is going to keep the gate open after the signal has exceeded the threshold. It's going to keep the gate open without minding all of these small holes right there in the sound. So let's do that.
We never felt so high, and we can't deny. This is where we come alive.
See, it takes some time to actually start gating out after the signal has passed under the threshold. So the hold parameter gives us the minimum amount of time that for sure the gate is going to stay open. So once the signal goes over the threshold, the hold parameter is going to keep the gate open for that amount of time. Now, this helps us immensely when we have the signal quickly going, you see, like right above the threshold, then under, right above, then under, in quick succession. It will stop that, immediate gating and letting go, gating and letting go. So this hold is actually going to soften that up for us. Now I can show you another gate plugin, just like that one. Let's try that. We also have a gate right here. Let's say this Pro G. And it's also a gate effect, just like the other one. We also have the transfer curve right there. So this is the threshold. We're setting the threshold when we want to start gating. And we also have the ratio. So how hard we want to actually attenuate the signal in what ratio after it passes under the threshold. We also have the attack and the release. We have the hold parameter. We have additionally a knee, just like in a compressor. See that? How fast it gets to that ratio. Of course, considering the actual volume of the sound under the threshold. So let's try that.
We've never felt so high, and we can't deny. This is where we come alive.
So that's nice. We also have the range. The range tells the actual gate how hard it can gate maximum. So what is the maximum amount of gain reduction that's going to happen every time the gate starts applying it? So let's say 20 dB, we can do that. We can input manually 20 dB, and that's the maximum amount of attenuation we're going to get. After that, the signal is let go to actually behave the way it actually would.
We've never felt so high, and we...
Now you see, I can hear the actual breathe in because I did that. If I do it all the way,
We've never felt so high, and we can't...
Yeah, we need to raise the threshold.
We've never felt so high, and we can't...
Now we're just having a tiny bit of that. Let's do that more. Let's give the knee completely.
We've never felt so high, and we...
Just a tiny bit of that breathing still.
We've never felt so high, and we can't deny. We've never felt so high. We've never felt so high. We've never felt so high, and we can't deny. This is where we come. We've never felt so high, and we...
That's it. It's done. So you can use any of these gates to achieve the similar effect. Some of them have expert settings like a sidechain piece of detection circuit. So in this detection circuit, you remember like in a compressor that we had, we also have the copy of the signal we are gating that's being listened to so that we could determine when to gate. Well, we can filter out what we are listening to so that the gate actually reacts only to certain amount of frequencies. We also have, you see that high cut and a low cut filter. So we can filter out a certain portion of the signal and just listen to that. And we can even hear what this gate is going to be listening to.
We've never felt so high, and we can't deny. This is where we come. We've never felt so high.
So you see, we're not listening to the S's, so we're losing those two. Many of special cases where we can use this, expert sidechaining kind of a tool where we can filter out what's being listened to and detected for the actual gate operation. But the most common usage would definitely be of the gate being used on vocals. And not just for these breathe ins, but for all of these silent parts of the vocal where the vocalist might not sing and just smack lips, do something. Well, instead of going there manually and deleting all of these parts like that, you can actually use a gate and get that dynamically done automatically for you.